Good morning, everyone. This is Shauna, and I'm coming to you today with a little bit of help for your discussion that's related to the linear regression. It looks very similar to the regression homework. There is a little nuance in this one that maybe you didn't see before, but let me share a screen at this time and show you what I'm talking about. So this is your discussion, okay? Is it necessary to visualize the data when we have fitted a line? Why or why not? In other words, why can't we? We're going to be talking about in this problem for a bit of context. She's given you some asteroids and their names, their average distances from the sun in millions of miles, and then their orbital period, which is the time it takes them to make one revolution around the sun in years. Okay, so Ceres, Pallas, Juno, Vesta, and so on. And it's tempting to just poke these in your calculator and get the data, and there's nothing wrong with that. But when you don't actually visualize the data first, some interesting things can happen. So what I'm going to do here, it says before you actually answer this, is it necessary? Why or why not? Before we actually answer this, we've got two other questions below here, but she wants us to do three things here. So what I'm going to do first is I'm going to make a scatter plot of the data. So here, we're going to do our usual thing with the scatter plot. I'm going to put it, I'm going to change my screen share to the calculator at this point. Okay, and I'm going to go ahead and do what we normally do for the scatter plot. So I'm going to get my data. I'm going to clear my L1. So let me clear that. Now, I'm going to go ahead and put in the data that you just saw. So average distances are going to be my L1, 257. Let me also do one thing here before I do that, and that is turn on the caption language. For those of you who are just joining us and missed the first part of what I said, I'm showing the discussion question, and I'm putting in the data from the discussion into the graphing calculator as I speak. Average distance, I'm going to put in my L1, 257.0. It's 257.0. Then I have 257.4. Then I have 247.8. Then I have 219.3. Then I have 239.3. I have 225.2. Two 21.4. 204.4. 221.7. And 222.6. That's my 10. Now I'm going to go to my L2 and I'm going to put in the distance, the orbital period, sorry. So this is 4.60, 4.61, 4.36, 3.63, 4.14, 3.78, 3.68, 3.27, 3.69, and 5.59. Now, I'm going to set my window here. You can use the Zoom 9 feature if you want. You can also set your window screen. I'll use the Zoom feature, Zoom 9 for Zoom stat. And I end up with this group of data points. And we have an outlier out here. You can see that this point here at the top of your data, this point here, he's off the beaten track with your line, and he's going to affect the R, the value of R. If I remove this point, my R will be a lot closer to 1 because these other points are a lot more linear than this makes it appear. Let me show you what I'm talking about. So we can do our usual, here's my graph, right? We can do our usual regression equation here by going to, let me get rid of that now. So I have, remember to find your regression equation, it's stat calc 4. So you're going to go to stat calc, option number 4, AX plus B, L1, L2, calculate it. And you end up with an A that's 0.0196. So A is 0.0196. I'm writing it off screen for a moment. I'll write it on screen in just a minute. And B is negative 0.3963. Negative 0.3963. And my R is 0.5128. So this is about 0.5128. Okay. It's 5129, right? 5129. Now, let's put that in your, let's put that in your y equals screen here. We have 0.0196x minus 0.3963. 3963. Let me make sure that I have my data points correct. I'm going to graph that. And we can see that my line is slightly off. My line, and that's because this point is pulling it up here. This point is pulling my R, okay? Going to stop my screen share and my record at this point, and then I'm going to come back to you. So now I've got this line, and let's take a look at our linear regression equation again. Let's take a look at that. This is, we're going to go ahead and calculate here. We have, so my regression equation here is going to be this. My regression equation is y equals 0.0196. I'm going to use 4 decimal places. 0.0196 x minus 0.3963. 3963. Okay. This is my regression equation. Okay. My R, my correlation coefficient is only 0.5129, which is not a very strong correlation, despite the fact that these points, let me go back and show you. If I go back to the line here, you can see that these points down here are closer to this line, and they're very close to a straight line. But this point being so far off is pulling that regression line off. And that's the one that's at 5. Okay. So that's what's happening here. If I want to show you something, remember what you see here. We're going to do a thing. I'm going to temporarily go to my stats over here, go to my edit here. And the one that has the 5 in there, this last point, I'm going to do something. I'm going to delete this temporarily. I'm going to delete my X value as well. I'm going to delete this point. I want to run this again for you. I'm going to delete this point. I'm going to take this line out because I want to show you something. If I took out that point, now I graph it. Notice these are very much closer together. Now let me run another step plot. So this was with, let me show it to you this way. Remember that this here was all the original points. All the original points, okay? Now this is with that 1 point removed. Watch what happens here. I'm going to run the stat calc again. Stat calc 4. Run it without that point in there. Look how much higher your R is. So with the outlier removed, here's my R. So if I remove it, I'll call this Y2. or y1. Y1 I'll call it. Y1 is equal to 0.0255, right? X minus 1.9551. 1.9551. Okay. That's this R, it goes to 0.999. It reduces, rounds, excuse me, to 9999. Okay. That's almost perfect, which is what you see when you look at the line here. So that's why it's important that you visualize the data. Is it important that we visualize the data when we are fitting a line? Yes, because here, this is the difference. This is the difference without the pair. Without the pair, and the pair was 222.6 and 5.59. Okay, this is our result without the pair. So notice how different they are. Okay, and if I graph this regression line, you would see it. But that's the difference. The regression equation obviously is different, but it's a much, much better fit without that outlier in there. Okay. That's what I wanted you to see. Now, what are you actually gonna graph? You're actually gonna graph it with all original points, but this is the difference that it makes. So when you do this exercise, let me write this down. Y1 is equal to 0.0255x minus 1.955. And R here was equal to 0.999. Okay. All right. Well, okay, I'm going to fix this now, but I wanted you to see that. So, and I don't think it makes sense unless you see the whole thing. I'm going to go back in and put my point in here. Start, go to my edit screen, put back the point that I removed. So this is 222.6 and 5.59. There's my data, okay? And again, there's my graph, right? There's my outlier, and here's my line of best fit. It was 0.0196x minus 1.9951 graphic. So this is your zoom 9 and a zoom 9 this. No, I'm gonna go ahead and quit from here. Get my window setting from my X is gonna go, I'm gonna take it from 0 to, I'll go to 300 and I'll scale it by 50, for example. My Y minimum, I'll go from 0 to 6. Scale this by 0.5 maybe, and graph that. Here's my graph. Okay, this something like this. Again, this is off. If I zoom this to fit the data points, then I'm looking at my window setting. I can zoom 9. There's my line. You can see that my line (0.01963) minus Z9. This is 1.9. Oh, I have the wrong, hold on. I have the wrong line here. I forgot to change this. 0.3963. Let's graph that. There's my data. Okay, so that's your curve. All right, so this is all original points. Okay, so what are you going to write for your, let me go to the homework, or the discussion, I should say. So it says make a scatter plot of the table. We did. Find the regression equation and graph it in the form y equals mx plus b. Okay, so if we're gonna do this thing, we're gonna make a scatter. Now, if you're gonna make a scatter plot and you're gonna copy it, I would suggest looking at your window. Your window goes from 199.1 to 262.7, scale of 50 with a minimum of, okay, they scaled it to about 2.8, maximum of 5.98, with a scale of 0.5 is what they used here. So this is your, so what we have is we're going to plot our points here. So here's my whiteboard. Okay. And I'm going to look at my whiteboard and I'm going to copy the data. So I'm going to draw here. Here's my curve. Something like that. My axis, I should say. Something like this. Okay. And my points are all really close to each other. They're between 200, about 204, and about 260. So I'm going to do like maybe this is gonna be what? Do like maybe 200 there, and then do this by 50s. So like, and if you skip, the other thing is if you skip, you can put like a little, let me erase this line. If you skip, you can put, there's a little technique to put a little thing here like this, and that means that you've skipped some numbers in between your hash marks. So what I'm going to do here is I'm going to say that this is, and the reason I'm doing that is this is going to be 200 here for me anyway. It's going to be 200, and then I'm going to have two. Okay, so I've got like, maybe I want this to be 210, and then I want it to be 220. So I want it to be the same distance apart. This is 220, and then 230, 240, 250, and I have to stretch it just a bit here, 250 and 260, 260 and 270. Okay, something like that is my grid. Okay, so I'm doing this here. That's my hash marks, so on, and they're about evenly spaced. There we go. And I'm just gonna plot these points. So I plot it. Now my y starts at 4. So I might do like, this is gonna be, they go from about 3 to about 6. So I'm gonna say that this is 1, 2, and this is gonna be 3, 4, 5, 6. Now this is going to be similar to that. Okay, so now we're going to plot our points. 257.0 and 4.6. 257 and 4.6. So somewhere up here, we'll have a point, right? Like that. Okay. Then 257.4 and 4.61. This is almost at the same place. It's just going to be over a little bit more. And it's essentially another tick mark that's the same. That's another point. It doesn't even look like it. They're so close together, right? And then here, this is going to be 247.8, okay? 247.8 and 4.36. 247.8 and 4.36. That's about here, let's say. Okay, maybe that's that point right there. Remember, we have 2 points that are really close together here. Now we have 219.3 and 3.63. 219.3 and 3.63, somewhere here maybe, right? It's going to be impossible to guess this, but somewhere there. Then we have 239.3 and 4.14. So somewhere up here, we have a point a little bit above 4, somewhere there. So we've got quite a linear line going here. Then we have 225.2, 225.2, and 3.78. So here, that's almost 4. So about maybe here, somewhere. Okay, got that one. Then we got 221.4 and 3.68. So somewhere up here, maybe we have a dot somewhere there. Okay. Now we have 204.4 and 3.27. So somewhere here. Okay. And then we have 221.7. So somewhere really close to there. And 3.69. So almost 4. So we're right about to here, maybe. Right about there. Oops. Right about there. Okay. And then we have 222.6 and 5.59, which is somewhere way up here. So this is my, whoops. This is my outlier right here. This is actually pretty much on the same line as my other data. This is my data. Okay. Now my regression equation, let me go back to the calculator. It's below most of those points. Okay. But there's a few, there's clustered. There's like 3 that are on a line and a couple that are off each other a little bit, right? Because these are rising a bit, but it's like it grazes these top 2 points. So this is not the best picture of what we're doing, but it looks something like this. I'm going to share. So what I do is this point here, and maybe I need to bring this one up a bit. Erase this point just a smidge. Let me erase a smidge and put it up just a little bit more. So this point is probably more like here. Okay, something like that. Now it's going to graze this point on the end, but if you look at the graph itself, it only grazes the top and then so something like this is where we would be. So something along this line. Let me switch colors for your regression line here. So something like this. It's gonna go down and it might graze this point and then it goes under most of them, right? So something like this. It's got to graze most of those points. So something like that is my regression. And let me make sure that I did that right, because actually I need the points to be below my line. So I have to do this again. I need the points to be below it. So these, yeah, I need to raise this. Let me erase this, because this regression line needs to be above these points. So here, this regression line needs to be above most of these. So it needs to go something like this. This is not quite what I needed, but I need it to be above most of those points. And it is. Something similar to that. Okay, that's my regression line. You'll have graph paper, so yours will be a little more accurate. Your regression equation here is y equals y equals 0.019 and 6x minus 0.3963. So that's your regression with your, and this is, remember, this x represents the average distance. in millions of miles. And this is your orbital period in years. Okay. Okay, so we have the at, then you're gonna get the next thing she wants after that is that she wants you to answer question 1. It takes about how many years for an asteroid that is 230 miles from the sun? So how many years does it take for an asteroid that is 230 million miles from the sun to make one revolution? And question 2, if an asteroid was discovered and astronomers knew its orbital period was almost exactly 4 years, what would you expect to be its distance from the sun? So in this case, looking at this now, we have two situations here. I'm going to go and look at the whiteboard once again. So that was question there. Then question one is, we're going to plug it into our regression here. So if we know that if a planet, or no, sorry, if an asteroid is 230 million miles away, what is the predicted orbital period? Well, we know that in that case, we're going to put 230. Remember, this is in millions already. So we're going to put y equals 0.0196 and 230, okay, minus 0.3963 into our calculator. So we're going to now go to the calculator and plug in 230. So I'm going to say 0.0196 multiplied by 230 minus 0.3963. This is about 4.1117. So I have comes out to about 4.1117 years. Now, the second question is, if they discovered, so if astronomers discovered an asteroid with a period almost exactly 4 years, what would be its distance? Well, something similar. I mean, I'm paraphrasing a bit, but that's essentially what's happening. So this time, the distance is x. So this time, y is 4. So we're putting 4 here, and we're solving for x. So we get 0.0196x minus 0.3963. Okay. Then I say, all right, let me add 0.3963 to both sides. So I have 4 plus 0.3963 is equal to 0.0196x minus 0.3963 plus 0.3963. It cancels out, right? In other words, these 3963s are going to cancel each other. And I end up with 4.3963, 4.3963 is equal to 0.0196x. And if I want to solve for x, then I need to divide both sides. So I get, I'm just going to sneak a line under here if I can. Let me sneak this up just a tad. And I'm going to divide it by this is going to be 0.0196. So this is going to be 0.0196 on both sides. And obviously on the other side as well. So I have, I'm going to do 0.96. And that's going to give me, let me draw a line under here so that you can see it. There we go. So what does that give me? Well, 4.3963 is, hold on, let me go and do the share screen here. So I get 4.3963, and I end up with, I'm dividing it by 0.0196. And that gives me about 224.3 miles. So, million miles. So I get this is X is 224.3, 224.3 million miles. Okay, so that's question 2 of your discussion. Now, don't forget to answer the original question. Okay, is this line how reliable are they, and all of that? And is it important to look at the data? And from the earlier discussion that I did, it is important. Okay. Don't forget to answer. These are your discussion points. Don't forget to answer this part, which is it important to view the data? Right? Well, yeah, it is, because we saw what happens when I remove this outlier. If you haven't watched the beginning of this video where I show you the difference between the regression equations, go back and watch it. But I would answer, as far as the discussion question goes, I would say, and let me show you the actual question again. Let me show you what we're looking at. So her original discussion was, is it necessary to visualize the data when you have fitted a line? Why or why not? And the reason for that is you're going to say, Yes. Oops. Yes, it is important to visualize the data when you have fitted a line, because outliers that are far off the regression line affect R, and make the estimates less reliable, something like that. You don't have to use exactly those words, but see, this R was only in the 50% range, if you remember when we did it. Whereas when we removed this outlier, it was a lot better, and it affects how good these estimates that you make from your data are. Okay, so I hope that helps you. That's it for this video. Look for more videos on 8.4 and the subsequent sections coming soon. Okay, take care. I'll see you in my next video. Bye for now.